Right now, you are hurtling through space at over 2 million kilometers per hour, and every second, the destination you will never reach gets farther away. You exist inside a bubble, not a metaphorical bubble, but a real boundary that defines everything you could ever possibly see or touch or know. Beyond that edge lies something so profound it challenges everything we think about existence itself. So what would happen if you could reach the edge of the universe? Would you hit a wall? Fall into nothingness? Or discover that reality is far stranger than any wall could ever be? The universe you live in stretches out in every direction for tens of billions of light years. Galaxies spiral through the void. Stars explode and collapse. Black holes devour everything that wanders too close. But all of this cosmic drama plays out within a sphere centered on you. Not because you are special, but because light has a speed limit. When you look at anything, you are looking into the past. The screen in front of you shows you light from nanoseconds ago. The sun you see is 8 minutes old. The stars you wish upon died centuries before you were born. And the most distant galaxies we can detect with our most powerful telescopes appear as they were over 13 billion years ago, when the universe was just a cosmic infant screaming its first light into existence. This creates something called the observable universe. It is not the entire universe, but rather the region from which light has had enough time to reach us since the Big Bang. The edge of this observable universe sits roughly 46 billion light-years away in every direction. Wait a minute. If the universe is only about 14 billion years old, how can we see something 46 billion light-years away?
The answer reveals something unsettling about reality itself. Space itself is expanding. Not expanding into something, but expanding as a something. The galaxies are not racing through space like ships on an ocean. The ocean itself is growing and carrying the ships with it. During the time light from distant galaxies has been traveling toward us, those galaxies have been swept even farther away by the expansion of space itself. But here is where things get truly strange. The observable universe has an edge from our perspective, but that edge is not a place. You could not travel to it. If you built a spacecraft and flew in one direction for trillions of years, you would never reach that boundary. It would recede from you at exactly the same rate you approach it, because it is defined by light that has not yet reached you. It is the horizon of time itself. Imagine standing on a beach, watching the horizon. You can see where the ocean meets the sky, but if you sail toward that line, it moves with you. The observable universe works the same way, except instead of an ocean of water, you are navigating an ocean of space-time itself. So, what lies beyond that cosmic horizon? This is where cosmology gets wild. There are three fundamental possibilities for the shape and fate of the universe, and each one gives us a different answer to what exists beyond the edge we can see. The first possibility is that the universe is flat. This does not mean flat like a piece of paper. It means that the geometry of space follows the rules you learned in school. Parallel lines never meet. The angles of a triangle add up to exactly 180 degrees. In a flat universe, space extends infinitely in all directions. There is no edge. If you could somehow freeze time and teleport across the cosmos, you would find more galaxies, more stars, more planets, forever. Our observable universe would just be one tiny patch in an endless cosmic tapestry.
But measurements from satellites observing the cosmic microwave background radiation suggest the universe might not be perfectly flat. It could have a slight curvature we have not yet detected. The second possibility is that the universe is closed with positive curvature. Imagine the surface of a sphere. If you start at one point and travel in a straight line, you eventually return to where you started. In a positively curved universe, if you could travel far enough in one direction, you would eventually loop back to your starting point. The universe would be finite but boundless, no edge to bump into, but also not infinite. Walk forever, and you are walking in cosmic circles. Here is where it gets even stranger. In a closed universe, if you looked through a powerful enough telescope in one direction, you might see the back of your own head, as light from your distant past finally completes its journey around the cosmos. The third possibility is that the universe has negative curvature, making it open and infinite like a saddle shape. In this geometry, parallel lines eventually diverge. The universe expands forever, and space stretches into infinity. Current observations from missions studying the cosmic microwave background suggest our universe appears to be remarkably flat, or very close to it. But we can only measure the curvature within our observable universe. The true global shape could be completely different. But there is another mind-bending possibility that scientists seriously consider. What if the universe has a topology that is finite but has no boundary? Think of the classic video game Pac-Man. When Pac-Man exits the right side of the screen, he reappears on the left side. The playing field is finite, but it has no edge. Some cosmologists propose the universe could work like this. Space could wrap around itself in complex ways, creating shapes like a three-dimensional donut called a torus. You could travel in what seems like a straight line and eventually return to your starting point without ever encountering a boundary.
If our universe has this kind of topology, we might be able to detect it. If space wraps around itself in a distance smaller than the observable universe, we would see repeating patterns in the distribution of galaxies or in the cosmic microwave background radiation. We would essentially see the same cosmic structures from multiple angles as light took different paths around the topology. So far, we have found no evidence of such repetition. Either the universe does not have a wrapped topology, or, if it does, the wrapping distance is larger than what we can observe. Now, let me tell you what actually happens at the edge of the observable universe, because this is where physics gets genuinely eerie. At the boundary of what we can see sits the cosmic microwave background radiation. This is the afterglow of the Big Bang itself. About 380,000 years after the universe began, it cooled enough for atoms to form. Before this moment, the universe was a hot plasma soup, so dense that light could not travel freely. Photons bounced constantly off charged particles, like someone trying to walk through an infinitely crowded room. But when atoms formed, the universe suddenly became transparent. Light that had been trapped was released and began its journey across the cosmos. That ancient light, stretched by billions of years of cosmic expansion, is what we detect as the cosmic microwave background. It comes from every direction, forming a shell around us. This shell marks the edge of our observable universe, not because nothing exists beyond it, but because we cannot see farther back in time than this moment of cosmic transparency. Beyond that shell lies something we can never observe, not because of technological limitations, but because of the fundamental structure of space-time itself. Light from those regions has not had time to reach us yet, and because of the accelerating expansion of the universe, it may never reach us.
Even more unsettling is this reality. There are galaxies beyond our cosmic horizon that are moving away from us faster than light can travel through expanding space. These galaxies are not breaking any laws of physics. Nothing is moving faster than light through space. But space itself is expanding so rapidly between us and them that the distance grows faster than light can cross it. This means there are entire regions of the universe that are forever beyond our reach, not just difficult to get to, but fundamentally inaccessible. Even if we could travel at the speed of light for eternity, we could never reach them. They exist in a realm that is causally disconnected from us. Events happening there can never affect us. Light from there can never reach here. For all practical purposes, they exist outside our universe, even though they are part of the same cosmos. As the universe continues to expand, and that expansion accelerates, more and more galaxies will slip beyond this cosmic horizon. Trillions of years from now, intelligent beings in our galaxy will look up at a night sky that is almost entirely empty. The distant galaxies we see today will have vanished, not because they were destroyed, but because they have been carried so far away that their light can no longer reach us. Eventually, only our local group of galaxies, held together by their mutual gravity, will remain visible. The rest of the cosmos will fade into permanent invisibility. Future astronomers will have no way to know that billions of other galaxies ever existed. The universe will appear to them as a small island of matter, surrounded by infinite darkness. This is the edge of the universe as we experience it, not a wall or a boundary, but a horizon defined by time and the expansion of space itself. But what if there actually is an edge? What if space simply stops somewhere? This possibility seems absurd to our intuition, but it raises profound questions. If space ends, what lies beyond that endpoint? Saying nothing exists there does not quite work, because nothing is still a concept that requires space to not exist in. The question itself might be meaningless, like asking, what is north of the North Pole?
Some theories in physics propose that our universe might be one of many. In eternal inflation models, the Big Bang was not a unique event, but one bubble in an endlessly inflating multiverse. Other universes could exist beyond our cosmic horizon, completely disconnected from ours, with different physical laws, different dimensions, perhaps even different kinds of particles and forces. In this scenario, our universe does have an edge of sorts. It is the boundary where our bubble of space-time meets other bubbles, or the still inflating space between them. But this edge would not be a place you could visit. It is beyond the cosmic horizon, beyond the reach of light or matter or any causal influence. The true shape of reality might be something our minds cannot fully grasp, because we evolved to understand only the local geometry of our small corner of existence. We are three-dimensional beings trying to comprehend a cosmos that might have dimensions and structures we cannot perceive. The universe might not have an edge, or it might be nothing but edges, depending on which theory turns out to be correct. What we call the universe might just be one tiny, finite region in an infinite landscape of existence. So when you look up at the night sky, remember that you are seeing only the tiniest fraction of what exists. Beyond the stars, beyond the galaxies, beyond even the cosmic microwave background, lies something vast and unknowable. The edge of the universe, if it exists at all, is not a destination, but a doorway into mysteries that might forever remain beyond human comprehension. And perhaps that is the most beautiful thing about existence. No matter how much we discover, there will always be another horizon calling us forward into the unknown.